Okay, kids, in this video what we're going to do is talk about rational numbers on a number line. Okay? And we're going to talk about how you can compare rational numbers on a number line. So to start this video, what we first want to do is ask ourselves this question. Because for some of us, the idea of a rational number, this is the very first time you're encountering it. A rational number is any number that can be shown as the quotient of two integers is a rational number. So any number that can be shown as the quotient of two integers is a rational number. Now that kind of is confusing, but basically what it is this. For any integers a and b not being 0, you will get a rational number. So in other words, if you look at a and b, these are both have to be integers. They can be positive, they can be negative. But when you look at this, you have dividing a, okay, a divided by b. So in other words, the quotient of two integers, okay, is what they're talking about here. So when you get a and b and you do the division, you get a rational number. Okay? And no matter whether it's positive or negative, as long as these two numbers are integers, you'll get a rational number because you will get a quotient. In other words, if you divide a by b and b is not 0 because you can't divide by 0, you would end up with a rational number. So for example, if you look at 3/4, okay, 3 is a positive integer, 4 is a positive integer, and if you were to divide those, you would get 75 hundredths. So remember, when you divide, and this is important, 3 is your dividend and 4 is your divisor. You're going to be dividing into a number that is smaller, so you want to start working with decimals. 4 will go into 3, can't do it, so you put a 0, annex a 0. 4 into 30 will go 7 times. 7 times 4 is 28, subtracting you have 2. Add a 0. 4 into 20 will go 5 times. 5 times 4 is 20, subtract, you end up with 0. So basically, 0.75 is a positive rational number. Alright? So that's basically what we mean by rational numbers. Now, where do rational numbers fit into the whole scheme of numbers? Well, here's a little diagram to help you understand it. When you were growing up, you first learned the counting numbers. 1, 2, 3, 4, and they went on forever. Then you learned about the whole numbers. Well, the whole numbers were the addition of 0 to your counting numbers. 1, 2, 3, 4, and on forever. Okay, so those were the counting numbers. All the counting numbers were a part of the whole numbers. Then this year, you were introduced to integers. Well, integers, alright, were all the positive numbers, 1, 2, 3, 4, and on for infinity, and all the negative numbers, -1, -2, -3, and on forever. So you had the integers. But you do know that in between 0 and 1 and 1 and 2, there are fractions. This is where the rational numbers come in. The rational numbers on a number line would be a positive 1.5, and then a positive 1, then a positive 1.5, and any fraction in between there, besides just a half, would be considered a rational number. And of course, if you go to the left on the number line, we know that we could have a negative half. We know that we could have a negative 1.5. We could continue. So this is what we mean by the rational numbers, and they are created through that formula I just showed you. Okay? So, now that you know what the rational numbers are, let's look at the rational numbers on a number line. Okay? Now, if we were to say that this is 0 and this is 1 whole unit, this would be positive 1. This would be positive 2. Of course, then this unit would be negative 1, and this would be negative 2. Then when we look at it, we say, well, certainly in between 0 and 1, you would have 1/2. So that would be a positive half. Or if you wrote it as a decimal, it would be a positive 5/10. And then, of course, you could have right there, that point, which would be a mixed number, a positive 1.5, or a positive 1.5. So that's the positive rational numbers. And, of course, each one of these has an opposite. So right here would be a negative half. Well, if it can be written as a negative half fraction, it can certainly be turned into a decimal, negative 5. And then, of course, if you're right here, you would have a negative 1.5, and you could also have a negative 1.5. Okay? And basically, it just means that you could have negative fractions and negative decimals, the same as you have positive fractions and positive decimals. And that's how rational numbers would look on a number line. Okay? So, now, let's just take a quick look at comparing them. Okay? So when you look at this, to compare rational numbers, follow these steps. Step 1, convert the fractions and mixed numbers to decimals. The reason I say convert them to decimals is because decimals are very easy to compare. You don't have to do a lot of work, and you don't have to be able to visualize fractions on a number line. So I always tell kids, if you're working with a mix of decimals and fractions and you're comparing them, just change your mixed numbers and fractions into decimals. So if you look at this, they want to compare which is greater, okay, or which is less. Where do they fit on the number line? Let's take our 4/3, negative 4/3, which is somewhere in between 0 and negative 1, and change it into a decimal. Okay? So what we want to do is we want to make 4 our dividend and 3 our divisor. Well, in this case, 3 will go into 4 one time. 1 times 3 is 3. Subtract, and you have 1. We're not done yet, so because we have to determine whether or not it's going to terminate or repeat. So we bring our decimal point up, and then we annex a 0. Bring that down, like so, and we have to ask ourselves, 3 will go into 10 3 times. 3 times 3 is 9. Subtract, and you get 1. At this point, you begin to realize that this is going to be a repeating decimal, because 3 will go into 10 3 times, and it'll just repeat the pattern over and over. So we're going to put the repeating symbol up there. So a negative 4/3 is actually, as decimal form, negative 1.3 repeating. Okay? So now we can compare those on a number line. This is where you have to really be careful. Okay, because remember, as you go left, numbers get lower. As you go right, they get greater. So we'd want to envision a negative 1 3/10. Okay, we'd come over 1 whole unit, and then 3/10, which would be 1, 2, 3. So this point right there represents negative 1 3/10. Then we would plot negative 1 and 5/10. Well, again, we would come over one whole unit and then 5/10. 1, 2, 3, 4, 5, which of course is the halfway point. So this would be negative 1 and 5/10. Well, because we are traveling left and this one is further to the left than this one is lower or has a lesser value than that one. So negative 4 and 3/10 is greater than negative 1 and 5/10. Alright? And so that's how you would figure out and compare. Just remember that it's always easier to convert fractions and mixed numbers to decimals. That's something that you can do quickly on your calculator. Alright? Let's take a look at a couple practice problems, or a practice problem. Let's see if you can pause the video and do this one on your own. See if you can compare these two rational numbers for greater than or less than. Pause the video. Alright, hopefully you did a good job of comparing them. Now, you may have used a calculator or you may have used division. I'm simply going to use division because I can't picture negative 3/8 on the number line down here. I have a general idea where it might be. In 11/12, negative 11/12, well, obviously this is going to be real close to one whole unit because it is obviously very close to having 12 out of 12. So obviously in this case we would know that this one is further to the left. But remember what your rules are. Okay, further to the left means less than. Okay, so in this case I know that 11/12 is pretty close to the one whole unit point here. And that means that 3/8 would somewhere be back in here. Okay, so I know that this would be greater than that. So here's what we're going to do. Just to be sure, I'm going to do the division. And I'm going to take 11 and divide it by 12. Because I want to show you a little trick here. 12 cannot go into 11. So we're going to put a decimal point in there and a decimal point in our quotient and annex a 0. 12 into 110 will go 9 times. 9 times 12. At this point we could actually stop. We could do 9 times 2 and get 18, carry the 1. 9 times 1 is 9 and 10. And we could do that, but we can see that if we do the subtraction it does work, so we have 9/10. That is good enough at this point. So now let's take this 3/8 and see what we get when we divide 3 by 8. Well, again, 8 can't go into 3, so I'm going to say it can't do that. I'm going to put my decimal point in there and annex a 0. We just need the tenths to compare. Alright? So 8 will go into 30, a total of 3 times. 3 times 8 is 24, and you can see that that works. So now we can see that this, a negative 3/8, is equal to 3/10, which would be right here on that point. So this is a negative 3/8 on the number line. And then if we look at this one, it's a negative 9/10, which would be way down here. So this is actually the location of a negative 11/12. This is further to the left, so it is less than. And that's how we got our comparison. Alrighty. Hopefully you have some understanding of what rational numbers are and where they are in the number line and how the rules of left and right, greater than, less than, still apply to these. Just remember that when you're comparing them, it's always easier to turn them into decimals than work with them as fractions. And you can always use a calculator to do that.